Hello, and welcome to another installment of How to Take Over the World with Basic Physics Concepts. Today's concepts include those such as induction, protons, electrons, opposites attract, likes repel, and there will be more later on in the episode. Well, the first thing we need to know is about protons and electrons. Protons and electrons are important because they're the smallest part of electricity and all that. So, protons are positive, electrons are negative, which means they attract each other. Protons repel protons, and electrons repel electrons. So, say I don't like Bob. I don't know why I don't like Bob, but Bob is a bad person. So, say we shoot Bob with a beam of pure electrons. He doesn't die. Somehow, he survives it and he's coated in pure electrons. And now, say that we shoot the ground around him in a coat of pure electrons. He would be shot up into the air like a rocket, the same way that when you hold two north ends of magnets together, they are forced apart. Well, another thing that we need to understand is induction. Induction is important because those cool little pads that you just put your phone on top and it charges, that is because induction. Induction is the act of enacting a force upon something else without physical contact. And I know what you're thinking, oh, it's on the mat. Well, yes and no. The reason it works is because it creates a field. Even though the field is very small, it's a field. So, within that field, electrons are allowed to freely move in the space. So they're attracted into the battery. I'm not sure how that works, but they are. It's important. They are. Now, the next thing puts a big hole in a great many of our plans because shoes. Darn society, darn their shoes, darn their need for conformity. But people own shoes. I own shoes, we all own shoes. And the problem with shoes is the rubber sole of the shoe. It makes them comfy, to walk. But they still let you get tased, but say you pee on an electric fence, it keeps you from dying because when you pee on an electric fence, all the electricity is dispersed by your shoes, which means if you had non-insulated shoes or non-rubberized shoes and you had conductive shoes with, say, for some reason you have copper wire running through your shoes, you would probably die if you peed on an electric fence. I'm sorry about you girls, but guys understand this, is that it wouldn't be fun. And girls couldn't pull that off. I'm sorry, girls. Now, force fields. Force fields work because air is also somewhat of a conductor. So electricity is allowed to freely move in the field that it is contained. So when electricity arcs from point A to point B, and we've all seen it where it's lightning goes from here to here, that's because it arced through the air using the molecules in air. Now, on to electricity. It is always a what kind of force is it? I'm sorry guys. I have to check my notes every once in a while. Can't be an evil genius always. It's kind of late. So, an electric field is an electric force pure unit of charge. This means that, see, this is why I don't have minions. This is why I write my own notes, because this is garbage. This is chicken scratch. And you know what? What I wouldn't kill for one of those little yellow minions right now. My God. Adorable, right? So, let me see here. An electric force is an attractive or impulsive interaction between two charged objects. So, again, say you rub a balloon on your head, that would charge the balloon with positive energy, while your hair remains negative. That would mean that the two are attracted to one another. That's the same way that if the balloon is already charged with positive energy, and then you go and stick it to a wall, the reason it would stick to a wall is because of the simple fact that it is already charged and it's still opposites attract. And then one very important thing, another fun concept, is the discharge of energy, or the flow of electrons. That is what it is. That is what static electricity is. That is what happens when you tase somebody, when you shoot them with a death beam slash lightning cannon, which apparently isn't legal in the United States. But yeah, I guess you live and learn. So, that is the flow of electrons. So, say I have a laser gun. You shoot it, correct? So then, after you shoot it, the electrons are moving. So, given that idea, if you shoot it over a long distance, the electrons would have dispersed. But if I'm tasing somebody and just zapped them, then that means that the flow of electrons have moved from the taser, or the taser's batteries, onto them, and they have felt the electrons move through them, and that is what that shock is. And the reason that works is because it interrupts the internal organs, interrupts the brain signals, and it messes up your muscles. So, big problem there. So, what can be gathered here today is that, first of all, a great many ideas that involve electricity don't work because your shoes are insulated. And the problem with that is that the insulation, or rubber, doesn't allow electrons to freely move among it because of how the particle is set up. The particles are tightly knit together, which means that the electrons cannot bounce from one particle to another very easily. Okay, next thing is that let's shoot Bob. First of all, we need to get rid of Bob. I don't like him. I don't want him around. Get rid of him. So, somebody help me out. I don't have the funds, but I do have the brains. Fund me. Let's get Miss Monitors here. I know that she licked the light pole just to see what a frozen light pole tastes like, and then wondered why she got stuck. I know that happened, but she has money. She can fund me. Same with Miss Pierce. Same with the guy up in Tokyo. It works. So, say you shoot it down at the floor. Say you shoot protons at the floor, shoot protons at him, it would shoot him up like a rocket. It's pretty cool. So, go on, my evil minions. Help me. Let's rule the world.